So now let's continue these examples under this work done. This another problem. They said a block of 225 kilogram on the floor is acted is acted upon by a push and pull forces incline at 45 degree and 30 degree respectively, as shown below, with the effect of gravitational pull balanced by a normal force, calculate the net work done. On the block in moving a horizontal distance. You can see underline the word horizontal. They indicate horizontal distance of 8.5 meter. So this is the diagram they're talking about. Let me draw it here. Talking about this diagram, we have something like this. So they say here. So here they say we have 10 Newton. So here we have 15 Newton. Here we have 30 degree. We have 40 degree here. And so the block itself move around this area, which is a 225 kilogram. So now we asked to find the work done here. This one is just like a resolution of forces. We talk about component of force, how to resolve a force, either horizontally or vertically. We discussed that in case if it means the vectors in our previous video, so please kindly try to watch that one too as well. So we said a vector under resolution of forces can be resolved in two ways, either horizontally or vertically. So now, but in the problem, it has been specified that we should go for horizontal. And recall, if you are resolving a force horizontally, we use cos. Horizontally, we use cos theta. If it is vertically, then we use sine theta. So since the problem now specified that we should go for horizontal, which one are we going to use? Yeah, we're going to apply for the cos. Now, so I can label them. Let's see here, you can see this one is F1, this is theta 1. You can say, no, this is mass now. I can find the force. You know that force is equal to mg here. So if I multiply 225 by 10, of course, here we have 2250. So here I can have the force here to be 2250 Newton. So you can say, the whole of this quadrant is our theta here now. So that means theta 2 here is going to be 90 degrees because it covers the whole quadrant. So here can be our theta 3, and here we can have F3, right? Now, so since we base on horizontal, that means I will go for horizontal. I don't need to go for vertical. Since the problem has specified that we should go for horizontal. If I'm resolving all those forces horizontally, the first one will be horizontally. The first one, that's going to be F1 cos theta 1. If it is vertically, it's going to be what? F1 sin theta 1. So now F1 cos theta 1, the second one is going to be F2 cos theta 2. Then the third one, you are going to have F3 cos theta 3. So please, if you use anything, you can say f of 10, or anyhow you use it, it's still the same thing. Just for you to, and you can label them anyhow you like. You can call this one x, this one y, or this one z. So now we know the work done. We know that work done is equal to force multiplied by distance, meaning the distance we go for each value that we have in that force. And from the problem, we are given that the distance is 8.5 meters. So how are we going to solve that? So I can have work done equal to the first one we have is F1 cos theta 1, the one we have on the first in the first quadrant. That is F1 cos theta 1 multiplied by distance 1. You know, work done is first times distance plus the second one we have here. That's going to be F2 cos theta 2. You know, the problem only based on horizontal. Assuming now it is vertical and horizontal, then I will resolve it horizontally. At the same time, I will resolve it vertically. As a F2 cos theta 2 multiplied by, sorry about that, it's still distance because distance is 1, it's 8.5. Plus the third one, that's F3 cos theta 3 multiplied by distance. You know, from here to here is work done still. You remember? Yeah. So this one too is still work done, even as well. This one is also work done. So here we can have work done equal to our first force we are given there is 10 multiplied by the distance. Anyhow you multiply it, you can say distance is 8.5 cos the angle we have in the first quadrant is 30. That's a cos 30 degree plus. But you know, in this quadrant, please, in case if you missed the previous video, just kindly watch that one. I break it down how to resolve your forces. In this quadrant, which one is positive there? Only cos is only sign is positive. All signs take chemistry. So now here I can have this one to be negative because my force is going to be negative. 2250 multiplied by cos. The angle we have is 90. So let's just say 8.5 multiplied by 90 cos 90 degree plus the third one. You know, in this quadrant, only cos is positive. So here we are safe. We don't have to have a negative. That's 15 multiplied by 8.5 multiplied by the angle we have there is cos 45. So now we can make a simple substitution here, and we have work done equal to the first one. So I can have 10 times 8.5. Of course, we are going to have 85. Cos 30 is nothing but 0.8660. I hope you are following, right? Plus, you know, this one, cos 90 is what? Is 0. So if you multiply all this by 0, you are going to have a 0. So that means I'm taking the third value now. That's going to be 15 times 8.5 times cos 45. I think that one is 0.7071. So let me check that one. Cos 45 is 0.7071. So now 85 multiplied by 0.8660. The first one, what I got is work done. I have 73.61, then plus 15 multiplied by 8.5 multiplied by 0.7071. In the second one, what I have is 90.15525, then plus the first result, 73.61. So if I do that, I have my work done here to be equal to 163.76 joule. So by approximation, so that means our work done here is equal to 163.76 joule. So we still have some problem that can relate to, you might ask us to find integrations, and it can come in form of you might be asked to find the work done, and you'll be asked to use integration method, because work done can come in any forms. You can have a problem that you have to find the work done, and it requires you to use integration. So let's take a look at that too as well. So that one's also simple and straightforward. Don't need to worry about that. So for that, let's see how we're going to make use of that approach. If you have to find the work done, and it's given in form of integrations, we also have that one too as well. It's simple and straightforward. So that one is given as this. Work done if it's a common form of integrations, work done is equal to integral over x1 or x1, let's say x2, x1, f of x dx plus integral over y2, y1, f of y dy. So this, if you are given only two direction, recall I talked about directional vectors ijk. So if you are given two, you stop here. But if you are given three, then we have this one too as well. Z2, Z1, f of z, then the z. It's just a simple integration, and I believe we learned how to integrate values, right? So for example, if I want to, let's say I want to integrate x squared. Yes, this is simple mathematics. This one is adding 1 to the power and divided by the power itself, meaning here we have x. You can see the power we have here is 2. That's going to be 2 plus 1 over 2 plus 1. So here we have x3 over 3. So here we are integrating respect to x. So in that work done, we'll be asked to integrate respect to x or respect to y or respect to z. It depends on the problem. If you only have two directions, that means you only take x and y. But if you have three directions, maybe we have ijk, that means we need to take the first one, the second one, as well the third one. So let's take a look at a simple problem from that. So you see x1, x2 we are putting here, it's representing the distance of the object. So an fx, fy, and fz will be given from the force. So the distance will be from one point to another. Let's look at this. It said if a force F equal to 2x squared I plus 3y squared j plus zk act on a particle and change the kinetic energy of the particle evaluate the work done as it changes position from A 2 meter, 1 meter, 0 meter to B 3 meter, and 1 meter. So now let's take a look at this problem and let's see how we are going to solve that one too as well. So now the question specified, they said if a force F is equal to 2x squared I plus 3y squared j plus zk act on a particle and changes the kinetic energy of the particle, evaluate the work done as it changes position from 2 meter, 1 meter, 0 meter to B. Just like, let me explain the concept of this one. This is going to be like x1, x for x, y for y, z for z, as it first component for the first component, second component for the second component, and the third component for the third component. Meaning this one is going to be x1, this is going to be x2. Here we are going to have y1, this is going to be y2, this is z1 as well, this is also z2, right? So I can see from the first, we are even 3. We have ijk, since we have ijk, then we apply this. So I can have work done here for the x. So for the x, you look at it, I have 3 and 2. So we can have 3, 2. Then for x, we have here is 2x squared dx. Then plus, for the second one, for y, I have 1 and 3. That's going to be 3, 1. And for the value itself, we have 3y squared, then dy. Plus the third one, for z, I have a 0 and 1. That's going to be 1, 0. The f of z is z. You can see it's simple and straightforward. We talked about the vectors earlier, the directions ijk in respect of our x, y, and z. So now we are going to integrate the first one, we integrate the second one, at the same time we integrate the third one, then we make a simple substitution. So from the first one, let me integrate the one after the other so that you can understand better. So for 2 x squared. If I integrate this, normally we had 1 to the power and divide it by the power itself. So here I will have 2x 2 plus 1 over 2 plus 1. So now here we have 2x 2 plus 1 and we have 3 over 3. So now we are given the limit there. We are given the upper limit and the lower limit to be 3 and 2. So if I put it here, I have 3 and 2. So I can factor out that 2 and 3. That is a 2 over 3. What we have now is a x cubed and 3 and 2. So now let's substitute the values. Upper limit minus lower limit. So we are going to have 2 over 3, meaning I will substitute for x when x is 3. Then minus I will substitute for x when x is 2. So here we have 3 cubed. That's for the upper limit. Minus, you can see the lower limit we have here is what? Yeah, good. 2. And we have 2 cubed. So here we are going to have 2 over 3. So 3 cubed. Is it 9? Can we say 9 for 3 cubed? And of course, 3 cubes simply means we multiply 3 in 3 times. So 3 times 3 times 3, and we have 27. So minus 2 cubed, of course, we are going to have 8. So here we have 2 over 3. 27 minus 8. What are we going to have there? Yeah, 19. Good. So here now we have 2 times, this one can just be 38 over 3. So let's find the value of that. That's 2 divided by 3. The first one we got 12.67. So if you divide this, we have 12.67 approximation. So that means the first one here we have is 12.67. Then plus you do the second one too, the same way, the same method. Let's do it here. Okay, let me use this side. I have 3y squared dy. So I want to just like the way we solve this one. I'm going to have 3y, 2 plus 1, that's going to be 3 over 3. Then we have 3, 1. 3 can cancel 3 here. What we have left is a y cube and 3 or 1. So upper limit is 3, the lower limit is 1. I can have 3 cube minus 1 cube. So 3 cube means 3 times 3 times 3. And as we said earlier, 27 minus 1. So here we have 26. So here we have 26 plus the third one, z. Just z is just like a power of 1. So if I integrate this, I will have 2 over 2. I can pull out the 2, 1 over 2, z1, 1, 0, right? You can practice this so that you can be able to show up your answer. So 1 over 2, that's going to be, upper limit is 1 minus 0. So 1 minus 0, you are going to have 1 over 2 here. So this one is going to give us 0.5. So now, when we solve the first one, we got 12.67. When we apply the second one, we have 26, and the third one we have 0.5. So let's add the 3 together now. 12.67 plus 26 plus 0.5. So what we have here is the first one we have. Confirm the result. If there's any error from here, divided by 3, 12.67, then plus for the second point that we have. So here we have 27 minus 1, that's 26. Then plus the third one, we have 0.5. So what we have is 39.17. So depending on the problem we are solving, it is joule. So the problem you have depends on how you are going to make use of the approach. So that's all about using the integration method to find the work done of an object or of a body. So I think then after that one we still have energy. That one is nothing but in that case, but I will include that one in the materials. Energy too, we have potential and we have kinetic as well. This one is dealing at energy at rest. This one is energy of motion, and this one is just like a secondary school where we know if you have to find the potential energy, that one is mgh, and for the kinetic, we use half mv squared. So we are going to include these two also in our material so that we can make use of that. So another one we have momentum. So when we have momentum, what is momentum in physics? Momentum is nothing but the product of mass and its velocity. So let's clean this one. So we have momentum. Momentum of an object is momentum. We have momentum. Momentum is the product of mass. What is time now? Okay, I will finish this one before 12:30 now. So momentum is the product of mass and its velocity. So meaning, so it's denoted by P, something like P. Denoted by P. Denoted by something like P. It's not P, but use that symbol. So that means we can say momentum is equal to mass multiplied by velocity. Meaning we can say momentum is equal to mv. But recall in that Newton's second law of motion, we derive one formula from there that we said F is equal to mass bracket of final minus initial over t. So if I cross multiply here, we can have Ft equal to m bracket of v minus u. So now, if I open the bracket of what we have at the right hand side, I can have Ft equal to, so m times v, we are going to have mv, then m times u, we are going to have mu. So this, we call it a change in momentum. From here we say momentum is mv, so what we have here is mv minus mg now. So here we call it a change in momentum. So it depends on the problem. If you ask to find the momentum, if you are given force and time, you can just say, so that means here I can say this momentum to is still Ft. And Ft in physics is what we call impulse of a momentum. Impulse of a momentum. So now, so that means if I'm solving a problem, I have to be careful with this. It depends on the approach of that particular problem. So we have Ft equal to m bracket of v minus u all over. So from here, if I open the bracket, m times v, we have mv, the m times u, we have mu. So this one we call it a change in momentum. There's another one we call it, how can we calculate? But we include all those things in our materials. You don't need to calculate about that. I just want to make everything, I want to round it up. We also have a way of calculating the common velocity of two objects. Hey, just note down all those formulas one after the other. With the one we have, we said momentum is equal to mass times velocity, right? And we say impulse of a momentum is also equal to Ft. So we have another one of common velocity between, we call it a principal conservation of linear momentum. So don't worry, I define all this one and based on the calculation here so that to make the problem more easier and faster. So we have, how can we determine the common velocity of two objects? Either they are moving in different directions or the same direction. Let me quickly prove that one for you. Then we solve like 3 examples. Then we round it up. From here, let's say I want to derive, look at the way I would derive it. Let's say I have two objects moving in two directions. Let's say F1 to be equal to minus F2 here. We know that normally we know F is equal to mv minus u over t. You recall, right? So this is, let's say I want this v to be my common velocity. In terms of 1, I can have m1 v minus u1 over t. Since they will have the same time, they will move in the same time, minus m2 bracket of v minus u2 then all over t. So no, if t cancel t here, what we have left here is that m1 v minus u1 is equal to minus m2 v minus u2. So if I open the bracket of these two, m1 times v, definitely we are going to have m1 v, m1 times u1, and we have m1 u1, m2 times v, and we have minus m2 v. So the second one, minus times minus here, of course. What are we going to have? Yeah, we are going to have plus. So we are going to have plus. We have m2 U2. So now, if I collect the like terms, moving the one without V to one side, and we have M1V, you can see this another V, right? That's going to be plus M2V is equal to, now, if I move this one to this side, we have M1U1 plus M2U2, just like we are just making a simple arrangement. So now, if you check this one, what do we have in common? Yeah, good. V, that's going to be M1 plus M2 is equal to, now this one we have M1U1 plus M2U2. So since I'm looking for this, if I divide all through by M1 plus M2 divided both side by M1 plus M2. So if this cancel this, we have common velocity of two objects is equal to M1U1 plus M2U2 divided by M1 plus M2. So in a situation by which we are given all the value, we have to find the common velocity of two objects. And if we even have to find the kinetic energy, we know kinetic energy is nothing but half mv squared. And from here, if it is two masses, we can have M1, M2, then all square of their final common velocity. So let's take a look at maybe one or two questions from here. So let's look at this. So now I can just include this one here. So if this maybe another direction, that means V now, common velocity is equal to M1U1 plus M2U2 divided by M1 plus M2. So now let's take a look at some examples. Maybe one examples. Since we have done that one under the Newton's second law of motion, so we don't need to waste time. In this case, they said an object of mass 5.0 kilogram moving with a velocity of 12 meter per second. Moving with a velocity of 12 meter per second. Due north. It's a stationary body of mass. It's a stationary body of mass 7 kilogram. If they stick together, after collision, and move with velocity, a velocity v. The question now said due north. That means they go in the same directions, right? Due north. Calculate v. So please, it depends on the problem. If they are moving in the different directions, I will include that in our material. The only difference is we are going to have a negative between them, but I will just include that one for you in our materials. So now, they said an object of mass, let's firstly write out the data. An object of mass 5 kilogram, our M1 is 5 kilogram, moving with a velocity of 12 meter per second. Our M2 is 12, our U1 rather, so U1 is 12 meter per second. Due north, it means it goes in the direction of north. It's a stationary body of mass 7 kilogram. You know, we have been given mass before, this is M1, so that means the M2 we have now is 7 kilogram. But you can see we have the value of U2 from the problem. So definitely there's no U2, so our U2 is going to be 0. I will explain all the reasons when we check our materials as well, so that you can see how we do that. Because it's a problem, you'll be given the complete result, the complete data. M1, U1, M2, U2. Just know the formulas, then you just apply them. So we decide if they stick together, that is after collision, they are moving the same velocity, and we have to find the value of our V. So now back to the formula that we derived, we said V is equal to M1 U1 plus M2 U2 divided by M1 plus M2. So now let's substitute. So V is equal to, our M1 is 5 multiplied by our U1 is 12, our M2 is 7, and our U2 is 0, divided by M1 is 5, M2 is 7. So 5 times 12 here, definitely, we are going to have 60. 7 times 0, we are going to have 0. So now, 5 plus 7, we are going to have 12. Then 60 divided by 12 is nothing but 5. So this is now 5 meters per second. So that's what we have. Even we also have a color of a gun, elastic and inelastic, but that one we are going to include all those ones in our material. So thanks for watching. This is what we have for dynamic, which includes the force and motion. Please don't forget to like our channel, try to subscribe and share so that other people too can benefit from our tutorial. So thanks for watching.